Welcome back to Series 2. In Series 1 of this explainer, we explored this foundational idea of persistence, basically why some things hold together in our universe while others just fall apart. Well, now we're taking a massive step forward. If General Emergence Mechanics, or GEM, is even partly right, what kind of future could we actually build? In this series, we're exploring some truly big possibilities. We're talking work-free abundance, AI and robotics, flying cities, personal air travel, self-lifting orbital habitats, long, slow sightseeing journeys through the solar system, even global weather shaping, distributed clean energy, and wearable coherence technology. Now, these aren't just empty promises or, simple predictions. They are future-facing thought experiments grounded entirely in the idea that stable systems work best when they cooperate with persistence. It's hopeful, curious, and maybe just a little bit bold. So if you enjoyed Series 1, welcome back. And please, hit that like and subscribe button if you'd like to follow the journey. Okay, let's dive right into this question. To really grasp what GEM implies for our future, we're going to scale our view today from the absolute birth of the cosmos, all the way down to a human-sized healing pod. We're going to look at what happens if the very laws of physics are, at their core, just the fundamental rules of maintaining stability. Here's our roadmap for today. Big possibilities: the multiverse, gravity, evolution, and coherence pods. We'll explore these thought experiments grounded entirely in the mechanics of stability. Section 1. The Cosmic Scale, a three-basin multiverse. Let's start our scale-down journey right at the absolute top. We're going to completely throw out the idea of an infinite string theory landscape, that vast ocean of infinite possible universes that critics often point out is totally unfalsifiable. Instead, modal theory and general emergence mechanics predict exactly 3 universes. Not infinity, just 3. And these are created by a single geometric structure known as a Z3 orbifold. This structure carves out exactly 3 distinct degenerate vacuum basins prior to symmetry breaking. It's an incredibly constrained, highly specific geometric prediction. Now, what's really fascinating here is how our universe, Basin 255, is simply the deepest global minimum of these 3. The other 2 basins, Basin 60 and Basin 180, are completely real, dynamical features of the vacuum landscape. But ours is the deepest well, and we're protected from the others by what GEM calls infinite persistence depth walls. So no, you can't just pack a bag and travel to them. They are safely locked behind absolute barriers of persistent space. So here is the absolutely crucial point. Our fundamental constants, the things we usually think of as just arbitrary numbers handed down by nature, are actually emergent features of our specific coherence shell's mechanics. Think about it. The speed of light? That's just the propagation speed of disturbances in the shell. Newton's gravitational constant is the strength of the depth gradient coupling. Planck's constant relates to the stochastic action scale, and Boltzmann's to how fluctuations convert to thermal behavior. They aren't independent primitives at all. They're all intrinsically tied to the mechanics of our specific basin. Section 2. The macro scale, rewriting gravity and dark matter. If our constants emerge from the persistent shell, well, we have to completely rethink how we understand gravity itself. In general emergence mechanics, gravity isn't a traditional invisible pull or some fundamental geometric force. Instead, it's an effective restoring tendency toward regions of greater persistence depth. Massive structures actually create local wells, or anomalies, in the persistence depth of the shell. So objects aren't being pulled like we're used to imagining, they're simply falling into deeper persistence wells within the shell, simply because the system favors regions where coherence is more strongly supported. And this framework brings a huge, game-changing consequence. Think about galactic rotation anomalies, the whole reason standard physics had to invent dark matter in the first place. In GEM, we might not need unseen, invisible dark matter particles at all. Instead, those excess gravitational pulls holding galaxies together might just be broad domains of anomalously elevated coherence depth. It's a structural feature of the shell itself, not some elusive ghost particle. Even time dilation makes total mechanical sense here. In GEM, time isn't a fundamental backdrop. It's literally just the directional relaxation of the shell toward its minimum. Because of this, it naturally follows that deeper persistence basins have slower relaxation times. Operationally, that means if you're in a deeper gravity well, meaning a deeper persistence depth, your local clocks physically run slower. Section 3. The planetary scale, the mechanics of evolution. As we scale down further to our own planet, we can bring these exact same persistence mechanics straight into the biological domain. Now, the standard model of evolution is driven by random mutation and survival of the fittest. But through the GEM lens, we can view random mutation as a stochastic or random exploration of persistent space. Natural selection then acts as a strict coherence filter. It's essentially the environment applying a persistence threshold to see what configurations are actually stable enough to stick around. Biological traits in species only survive if they can stay above that persistence threshold. Configurations can be stable, metastable, transient, or completely non-persistent. The really fascinating takeaway here is that biological complexity increases naturally, not because complexity is some end goal, but because life is constantly forced to find deeper, more robust, higher dimensional basins to occupy whenever the environment shifts. Consequently, the Great Dyings, those massive extinction events in Earth's history, aren't just runs of terrible ecological luck. In GEM terms, they are large-scale shell failures. They happen when massive environmental gradients reduce the effective persistence depth completely below the survival threshold for a massive number of lineages all at once. It's quite literally a collapse of the local biological coherence shell. Section 4. The Human Scale, the Biological Coherence Pod. Now, let's shrink this all the way down to the individual human scale. If biology is fundamentally governed by these rules of persistence, could we artificially engineer a controlled environment to help our bodies heal? If we interpret physiological failure, things like chronic stress, extreme fatigue, and disease, as a drift away from a stable biological basin, then recovery takes on a whole new meaning. Recovery is simply the successful mechanical return toward biological coherence. It's about guiding the body back into a deep, stable persistence well. To achieve this, we can look at the layer logic of a speculative biological coherence pod. Rather than just a wearable suit, a pod offers a much more stable, controlled interior space. It consists of an inner interface, posture geometry, chamber shell, an actuation layer, and external control. It's designed to create a low-noise, sensor-rich shell around a resting human subject, defining a highly regulated local environment right around the body. By continuously measuring biological proxies, things like your effective depth, your effective stiffness, and effective viscosity, the pod could run a closed-loop control system. Using data like heart rate variability and spatial temperature, the pod's actuation layer could apply incredibly low-intensity, structured modulation. We're talking gentle thermal zoning or vibromechanical stimulation to gently guide your body back to a stable, persistent state. It is literally an engineered coherence shell for human recovery. Section 5, a future built on persistence, tying it all together. We've scaled all the way from a geometrically constrained three-basin multiverse down to an engineered human healing pod. And the through line connecting all of this is absolutely seamless. The observable universe is a dynamical coherence shell. Whether we're talking about the orbit of distant galaxies, the emergence of the speed of light, the survival of a species, or literally the beating of your own heart recovering from stress, it is all just the struggle to maintain stability inside a dynamical coherence shell. Persistence is the universal rule. These are, of course, future-facing thought experiments. But if General Emergence Mechanics is even partly right, if stability, recovery, and existence itself are governed by these mechanical laws of depth, stiffness, and relaxation, what kind of future will you choose to build in a persistent universe? Because the tools to shape that future might finally be coming into our grasp. Thanks so much for joining me for the start of Series 2. Please remember to like and subscribe if you'd like to follow along on this journey, and I will catch you in the next explainer.